Hey, this is Mr. A, and we're going to work through how I want you to write up the project. So what you'll need for this video is you'll need your handy dandy calculator, the one that you know and love. I want you to print out a copy of the project description, which has the steps by steps that I want you to take. And then of course you're going to need some paper and a pencil, and this is what I'm going to work on to model how I want you to write up the report. Alright, the first thing that you want to do with your paper is to put a title on here, and you're doing the Earth-Moon project, but I'm not going to do the project for you, so I need to do something a little bit differently. I am going to be doing a scale model of the Earth and Sun. So Earth, right? So I'm doing a different example, but the steps that you go through, what I'm going to show you will be exactly the same. Okay? So start with the title. And then step 1 says write a statement of purpose for, what are we doing and why. So again, you can look on the project description, and here I give you what I think the purpose of the project is, and you should come up with something similar. Please don't copy what I wrote. You can come up with your own words. Okay? Step 2 is I want you to list the sizes of the known objects. So in my case, the diameter of the Sun is equal to 150 billion meters. The diameter of the Earth is equal to 13 million meters, and the distance in between is equal to 150 billion meters. Okay, so that's step 2. Step 3 is I want you to state the size of one of the objects. One of the examples that we have been using in class is that the Sun is the size of a beach ball. So here we are on step 2. Step 3, consider a beach ball for the Sun. And beach ball diameter is, so I'm going to put S is equal to 0.6 meters. So this is, S represents the diameter of the Sun. All right. Step number 4 wants you to calculate a scale factor. So scale factor. So scale factor is, let me move this up a little bit. Scale factor is the diameter of the real Sun, 1.5 times 10 to the 11, divided by the diameter of the scale Sun, which is 0.6. Okay, so now you're going to need your calculator, and I'll try to get the light on this right. So it is 1.4 e to the 9 divided by 0.6. Enter. The scale factor is 2.3 times 10 to the 9. That's a really big scale factor, and that's what we should expect, is big scale factors. All right. So the next item on the to-do list here is to calculate the diameter of the scale Earth. So if the scale factor is this, the model Earth is using the equations that we have been working with all along. the diameter of the Earth in the scale is going to be equal to the diameter of the real Earth divided by the scale factor. All right, so we're getting way down here at the bottom of the page, but anyway, the diameter of the Earth in the scale world is going to be the diameter of the Earth in the real world, 1.3 times 10 to the minus 7 meters, divided by the scale factor, 2.3 times 10 to the 10. So if I get my calculator out here and I enter 1.3 e to the 7 divided by 2.3 e to the 9, then, e to the 9, I get 5.6 times 10 to the minus 3 meters. That's pretty small. I wonder what that is in centimeters or millimeters. In fact, that is actually what I wanted you to do for number 6. All right, so we're going to need to flip our page over to do that. Okay, we're going to convert to appropriate units. And you could argue with me whether 0.6 meters is an appropriate unit or not. But I'm going to say, hey, if it's less than a meter, then I want to see it in centimeters. And if it's less than a centimeter, I want to see it in millimeters. So with the scale model of the sun being 0.6 millimeters, I want to know what that is equal to in centimeters. So we have a method of converting that, right? So if what we've got is 0.6 meters, we need to multiply it by some conversion factor where we've got centimeters in the numerator and meters in the denominator. And to make this relationship equal to 1, because we can't really change the number, but if we multiply it times 1, we really haven't changed it. So that we know that there are 100 centimeters in 1 meter. So 0.6 times 100 is equal to 60 centimeters, right? So that would be the factor you'd use to convert meters to centimeters. And maybe you can just look at it. You've not probably done enough of these that you can just look at it and convert 0.6 meters to 60 centimeters. Now, for the Earth, which is 5.6 times 10 to the minus 3 meters, that's really pretty small. And we need to convert that to appropriate units. And so what units are you going to convert it to? And let me just give you a rule of thumb, I guess. If you calculate a number and you get something that is times 10 to the minus 2, then you want to see centimeters. We're talking about length here. And if you see something that's times 10 to the minus 3, you want to see millimeters. Those are really the appropriate units. So if you see exponents in this range, right? And there's also to the minus 6, which is micrometer, and minus 9, which is okay. It goes on. Anyway, we want to see millimeters here, right? So the way we convert that is 5.6 times 10 to the minus 3 times some conversion factor. We want millimeters in the top, and we've got meters in the bottom. So in 1 meter there are 1,000. There's 1,000 millimeters, and so if we multiply that out, it's just 5.6 millimeters. Right. All right. Wow, wasn't that convenient? Okay, so now we have expressed our objects in appropriate units. All right, so we're moving on to the next bullet. Okay, so now we're moving on to the scale distance between the Earth and the Sun. So if the distance between the Earth and the Sun in the scale world is equal to the distance between the Earth and the Sun in the real world divided by the scale factor. Okay, that is 1.5 e to the 11 divided by scale factor 2.3 e to the 9. Okay. All right. That turned out to be 6.5 meters. Wow, okay, so we're almost done. That was step 7, in which we were to say what the scale distance is between the Earth and the Sun. Now the last thing you have to do is show me that this fits in the classroom. All right, does this fit in classroom? Does it fit? Well, I told you that the classroom is 5 meters. And 5 meters, my model is 6.5 meters. 6.5 meters is greater than 5 meters. And does it fit? The answer is no. Man, I got to go back, and I got to go all the way back. I got to go all the way back, and I got to pick a different sized object in order to represent the sun. So this is where you're going to have to go back and do it all over again, because this is a requirement. Your model has to fit in the classroom. It has to be less than 5 meters when you calculate that distance. Okay, so it might take you a couple of times in order to be able to do this. But let's see, a couple of points that I want to make now is, if you go back and you look at my calculations, I carried through 2 digits. That's the kind of precision that I want you to carry through. You don't need to carry a bunch of numbers through. So if you just carried through 1 digit to the right of the decimal in scientific notation, that'll make me happy, and you won't have a bunch of numbers all over your page. The other thing that I want to point out is that I had a very conveniently sized the beach ball I chose as a convenient size for my son. But what happened is when I went and I calculated then what my Earth is going to be, that was 5.6 millimeters. That means I've got to go find an object which is 5.6 millimeters. That's a half a centimeter. That is half a centimeter. That is, let's see, this is 2, that's 1. Okay, that's like a half of my pinky finger in width. That's a really small ball. That is bigger than a BB, smaller than a marble, and so you might actually have some difficulty finding that object. Well, anyway, I don't want to get you too dismayed, because really, again, I was doing my model of the Earth and the Sun. You're going to be doing yours of the Earth and the Moon. So, you know what? It might work out differently from you, that the object that you choose to represent one of your objects is perfectly fine when it comes down to the bottom. But just remember that I'm gonna hold you accountable to that requirement that your model fit inside the classroom. Okay, so I didn't do it on 2 pieces of paper. I mean, on 1 piece of paper. I was able to actually do it on 2 pieces of paper, and it took me a lot longer than the video, of course, because I was preparing myself and double checking my calculations. But to be honest, if you sit down and give it your honest attention for a good hour, I think you'll make a lot of good progress. Okay, that's my video. Thank you for watching.